Hi friends, in this video I'll discuss about natural language processing. Natural language processing is an important aspect of artificial intelligence and development. Natural language processing focuses on system development that allows computers to communicate with people using everyday language. We have generally two categories of languages, one formal language and other natural language. Formal language refers to any structured language with specific terms and rules or syntax. For example, programming languages like Python is kind of formal language. Generally speaking, they possess non-ambiguous rules. You can see an example where in Python syntax we have form of good syntax and bad syntax. You can see examples here of good and bad syntax in Python language. For example, sum equals to 2 plus 2, example of good syntax, and 2 plus 2 equals sum. This is example of bad syntax. So generally speaking, in formal language, there are non-ambiguous rules. Natural language, on the other hand, refers to human languages we use to communicate with every day. Unlike formal language definition, natural languages contain ambiguous, vague, and even contradictory rules. For example, in English, if you say two men took too many bottles to their spouses, so here the word two, that is TWO, TOO, and TO. So all these have same pronunciation but different meanings. So imagine how complex a task it can be for an artificial intelligent agent to learn a language. So let's dig deeper with a few terms. The field of natural language processing is divided into two categories. First, natural language understanding, that is NLU, and the other is natural language generation, that is NLG. So natural language understanding is something where the process of understanding natural language takes place. Natural language generation, this is the process of creating human language that human can understand. In few terms we have in natural language processing, that is speech recognition, which is the process of transcribing audible sounds into strings that can be recognized. We have speech synthesis, which is the process of creating audible words that can be understood by humans. So these are the tasks that an AI agent needs in order to communicate. Now let's discuss components of natural language processing. Syntax analysis. This is the structure of sentences and the purpose of words. So how you put words together to make meaningful statement. We have morphology, refers to the structure of words like the meaning, the part of speech, pronunciation, and so on. Part of speech tagging is used to identify grammatical group such as subject, verb, and so on. Then we have extraction, where relevant words are extracted which has a meaning in the context of given statement. Semantics is the understanding of sentences. We have lexical semantics is the meaning of a word in a given sentence. So context. And lastly, we have a component of natural language processing which is known as discourse. So discourse is the understanding of interaction between sentences. Discourse analysis is the analysis of relationship between sentences. Now let's discuss about basic natural language processing operations. These are regular expressions, tokenization, stop word filtering, tagging, and stemming. So if we talk about regex, a regular expression or regex is a sequence of characters that define a search pattern. Regular expressions are extremely useful in extracting information from any text by searching for one or more matches of a specific search pattern. Now let's talk about tokenization. So tokenization splits text into two words and sentences. Basically a task of chopping a character into pieces, called as token, and throwing away the certain characters at the same time, like punctuations, and its core task for many natural language processing operations. We have stop word filtering. It refers to stop words which aren't necessary for natural language processing, tasks to understand the meaning of a sentence. Tagging. Tagging is the process of identifying and classifying components. Tagging is done using list of entities and special algorithms. Part of speech tagging determines grammatical group of words, so the subject, object, verb, and so on. This tagging is done with the list of words, a part of speech combination, and special algorithms. Then there is stemming, which seeks to simplify words in order to reduce vocabulary selections. A stem is a base word without prefixes or suffixes, the root word. So for example, transformation become transform and conditional become condition. And useless double letters are removed. It makes processing more efficient and frankly quicker. Stemming is usually done with a set of rules. Then we have named entity recognition, that is also known as NER. It identifies and classifies named entities. That is a person, a location, an organization, and so on. So named entity recognition tags named entities. And this can be done with a list of entities and special algorithms. Named entities are objects with a name. For example, in a sentence, Billy went to Toronto in May. So Billy is classified as a person. Toronto is classified as a location, and May is classified as a time. So named entity recognition is used for parsing language, that is analyzing and understanding it for information retrieval and question answering for conversation and for understanding relationships inside sentence structure. So let's discuss about natural language process and the models that are used to build them. So we have n-gram model, which is a continuous sequence of n tokens found in speech or text. An n-gram is a sequence of n words. A 2-gram or bigram is a 2-word sequence of word like please turn, your homework. And a 3-gram or a trigram is a 3-word sequence of words like please turn your or turn your homework. So n-gram helps you to find words that have meaning together. Then another natural language processing model, we have the bag of words model. This model makes a bag of all words in the vocabulary. For each document, the frequency of each word is counted, and only the frequency of words are considered, not the word order or the relationships. Here are some examples. Document 1 contains the word the apple. Document 2 contains the word the green apple. So here resulting bag of words would be the green apple. And so you could see the frequency captured here, the word the appearing only in document 2 and the word apple also appearing in both documents. Then we have text classification. Naive-Bayes classification is used as a simple text classification algorithm in NLP or natural language processing. This method for classifying text by assuming that all features are independent of each other. That is, it doesn't consider word relationships, or where the words are positioned. For example, given the text Bob eat corn, corn eat Bobs is treated the same way. Now let's talk about information retrieval in natural language processing. So information retrieval here refers to a process where sources of information, say a set of libraries or catalogs containing common terms, are scrubbed from pertinent sources. The goal is that, given a query, a subset of documents should be returned from a larger set of the document, and that subset should contain relevant information for the task at hand. For example, a search engine query would find relevant web pages that contains what you are searching on. Then we have a task answering questions in natural language processing. So in artificial intelligence, AI agent can use simple information retrieval techniques to answer some simple questions. Question answering is a derivative of information retrieval. In this scenario, a question is given instead of a query. For example, who is president or what is the capital of Germany? In question answering, a specific line of text is expected instead of a list of documents. Then we have parsing. So in natural language processing, parsing or syntactic analysis, it is the activity of splitting sentences into grammatical groups. Then we have machine translation. Statistical machine translation, or SMT, is a translation method where translation is based on statistical models. So the goal of statistical machine translation is to take input from one language, say English, and pass it on for translation to another language like French. So to conclude our understanding on NLP, or natural language processing, we first list the basic operations of natural language processing, that are regular expressions or regex, tokenization, stop word filtering, tagging, and stemming. So this was the understanding of conceptual part of natural language processing. In my next video of this series, we will move further and focus on learning Python scripting language so that we can develop insight in scripting programming part as well, and strengthen our development skill to understand artificial intelligence and machine learning from programming aspects and at implementation level. That will broaden up our understanding of machine learning and its implementation in our daily life. Thanks for watching this video. See you all in the next video. Till then, goodbye.